Hey guys, I'm doing this from study hall, so if you hear any like immature ninth graders, that's just these guys in the back. Josh, what's his name? Drazo, yeah. And then some of these other guys, Nick something. Touche, like Bobby Boucher. Those guys get really kind of feisty back there, so I might have to pause it and whip them into shape a little bit. But first thing you should always do is put your name on this. So Larry the mechanic. Okay, he's going to be taking this one. So you're solving absolute value equation. So the first thing you want to do is get that absolute value stuff. That's this. This is the absolute value stuff right here. We've been talking about this. Get that all by itself. So you want to get that all by itself on its own side of the equation. There's a little equation side. So the first thing you got to do is fire this 12 over there. Okay, so you get that over there by adding it, right? So you're going to add 12 to both sides. Get that over there. That's going to turn the other side into what? 8. Okay. So now we got 8 over on the other side. So it's like 2 times the stuff. Okay, and then that's equal to 8. And then how do I get rid of that 2? It's like being times by the stuff, right? So if it's times by the stuff, how do you get rid of times? What undoes times? If somebody's fighting you with times, what are you going to block their fight with? Divide. Good. Yeah, divide. Wow, this study hall is pumped up about math. So we're going to divide by 2. Boom. That gets rid of that stuff right there, and now we got the absolute value stuff all by itself. That's good, because here's the deal with this. Because absolute value always does what to the numbers? What does it always do? Oh, it makes it positive. Okay, this class is pretty good. So like, just because it always makes it positive, when that stuff inside of there, when that stuff equals 4, that's going to be true, right? When it's positive 4. Also, when that stuff inside of there equals negative 4, since we have the absolute value, it's going to also be true. That's why we're going to have to consider positive case, negative case. So when does the stuff equal 4? And when does the stuff equal negative 4? And then when that's true, two values, this problem will be I can't really talk. Those values for x are going to be make the equation true. So we'll do a little, some fun little algebra here. We'll take 1 away from both sides. 3x equals 3. Yay, it works out perfect. Happy math book problem. X is 1 on that one. And then over here I minus 1 from both sides, and I get 3x equals negative 5. Students hate this. They're like, oh my god, it's a fraction. I must have done something wrong. Right? But you actually didn't do anything wrong. You get it right. So you divide both sides by 3, and you get negative 5/3. You know what a lot of people goof up on like tests and stuff when they screw this up? They're going to put 3/5. Okay? So when Josh just slapped this kid in the back. You know what? Your day is coming, buddy. Okay? All right? So anyway, sorry about that. Don't get them upside down, and pay attention to what you're doing. Okay? Sometimes if you make mistakes a lot, just divide both sides by 3 like that, then you can get it right. Okay? Negative 5/3. Two values that when you plug it in for this variable in here for x, make that equation true. We're back. So we have inequality now. The difference here now, check this out, is we have an inequality. That's a greater than. It's different now when we have an inequality, because like when you have an inequality, the amount of numbers that make this whole thing true is going to be like an infinite amount of numbers. That's why we have to make a number line, isn't it? Right. You're at home right now shaking your head. Yep, that's right. Okay. So same deal, you got to get the stuff by itself, and so when we get the stuff by itself, I got to divide by a negative 5. Ooh, whoa. If you divide an inequality by a negative, you must flip it. You flip the symbol. Yes, flip the symbol. So now we flip the symbol around. Those are canceled out. Okay, we have the absolute value, x minus 12. You flip the symbol. That's going to be a less than positive 4. Okay, good. Is that even possible for the absolute value of something to be less than 4? Yeah, it's totally possible. Okay, but if it said less than negative 4, it wouldn't be possible. So sometimes you want to just stop and just make sure this is even possible to do. Okay, now what you're going to do is you're going to solve for the positive and negative case for where it's equal. So like, when does x minus 12 equal 4? And then like, when does x minus 12 equal negative 4? because you know what's going to happen then is when we're all said and done here, we're going to graph this on a number line. This is like the test point method. So we're going to have 2 points on this number line that we're going to have like boundary points, okay? So the boundary points there, add 12 to both sides. That's going to be a 16, add 12 to both sides over here, and that's going to be, oh, my smartboard's tweaking out. You gotta talk nice to it. Come on, smartboard, baby sweetie, let's go. I know that sometimes I go too fast for you. Oh, see? It works every time when I talk to it. I'm serious. Okay, we're back in business. So plus 12 on both sides. Negative 4 plus 12 is going to be 8. So we got positive 8. So now what I did is I found my boundaries there. I found the points where they're equal. Hold on, I got to pause this and get the ruler. All right, we're back. We had to put out a fire. So we need to test now. We need to test. The easiest point to test is 0. So I'm going to test x equals 0 over here and see if it's true or if it's false. And that'll determine kind of where this solution is. So if I put 0 in for x, okay, does that make this true or false? 0 minus 12 is negative 12. The absolute value makes it positive 12. Positive 12, is it less than 4? No, it's not. So it's going to be false over here. So if it's false over there, it's going to be true in between here. Now this always kind of shocks me. It's not that hard to write the inequality that goes with this. All right? I think people just don't listen to me. There you go. One compound inequality. So many people just forget to write the actual inequality answer. They just put the graph. I want the inequality answer, and when it's a compound inequality like that, it's and. You can write it in one statement just like so. Okay? All right, good deal. I'll set up the next problem. Time out. Last problem, number 3, we have a whole bunch of fractions in it. Everybody loves fractions. They're so fun to work with, aren't they? It's like, I just love all these fractions. Okay? Well, if you're not a fraction lover like most people, then you just want to get rid of those fractions by making all the denominators the same. So get all the denominators to match, and then you can just forget about the denominators. Okay? So 5/2, between 2 and 5, what's the least common multiple? 10. Good. Okay, so let's get all of them to be 10s. So I'm going to multiply this one by 2 over, no, just kidding. Just kidding. Just kidding. Multiply this one by 5 over 5. All right. I'm going to multiply this middle one by 2 over 2. And I'm going to multiply this last one here by another 5 over 5. Okay. Hey, how come you're able to just multiply them by like 5 over 5? What's the deal with that? Why is that okay to do? Aren't you changing the problem? No, you're not, because you're just multiplying by 1, and 1 doesn't do anything when you multiply by. So 5 over 5 times 5/2, that's going to be 25 tenths. Okay, but it's actually x, so it's 25x over 10. Plus, over here I have 2 times 3 is 6 over 10, which that makes sense. 6 tenths is the same as 3/5. And then 1/2, that's the same as 5 tenths. That's a neat little trick because now you have all the denominators the same. Well, just forget about it. Don't worry about it. Just forget about those. Okay, good. Forget about those. So now we have 25x plus 6 equal to 5. Solve for x. This is like a little baby algebra 2, algebra 1 question. Okay, this is like a question for babies now. 25x minus the 6 from both sides equals -1. Now, some people might just put like -25 as their answer because they jump to conclusions. You know, it's like a jump to conclusions mat with all different conclusions you can jump to. All right, so you write it out. Boom, cross those off. X is equal to -1/25. Hey, does anyone know what that as a decimal is? -1/25? No, 0.4 would be 20. 0.04. Ah, good. All right. And if you're like a calculator peep, then you would be like -0. What was it? 0.04. Bada bing. Okay. Hey, that's good. Under 10 minutes. I won today. I'm the winner.